Somewhere in the infinite night, our solar system drifts through the galactic sea, a fragile island of warmth surrounded by endless cold. 8 planets circle a single yellow star, connected by gravity's silent pull, each world moving in rhythm, like dancers bound to the same celestial song. Beyond Neptune's orbit, the light fades into interstellar darkness, and every atom of us longs to see what lies beyond. But there is a quiet truth written in the laws of physics and reflected in the limits of our own nature. We may never truly leave. Not because we lack imagination or courage, but because the universe itself seems to whisper, "Stay here. This is where you belong." Like and subscribe if you find peace in the mysteries above. Join us as we drift into the cosmic unknown. Let's begin. At 100 astronomical units from the Sun, sunlight takes nearly 14 hours to reach you. Here, beyond Pluto, the solar wind weakens into silence. This is where our star's influence fades, the border between the known and the infinite. Out here, sunlight no longer warms your skin. It's thin, distant, just a faint shimmer stretched across the black. The sun, once bright and golden in our sky, now looks like a small white spark against an endless backdrop of stars. The light that reaches this far is weak and cold, like the last ember of a dying fire. This is the edge of the heliosphere, the invisible bubble blown by our sun. For billions of miles, solar wind streams outward, creating a glowing cocoon around the planets. But even stars have limits. Eventually that wind meets the resistance of interstellar space and begins to fade. Here, at the heliopause, the sun's influence ends and the galaxy begins. Crossing this boundary would feel like stepping through a silent door. Behind you lies the warmth of home, radiation, magnetism, and the faint pull of gravity that connects every planet to the sun. Ahead is the interstellar medium, a thin fog of ancient atoms drifting between the stars for millions of years. It's not empty, but it's close. Only 2 human-made objects have ever reached this place, Voyager 1 and Voyager 2. Launched in the 1970s, they now drift through this twilight region. Small, silent messengers carrying golden records with the sounds of Earth. They move through a space where the sun no longer shines on them, only glows behind like a distant memory. Their radio signals, barely a whisper, take over 20 hours to reach us. Each year, those signals grow fainter, swallowed by distance. If you could stand here, you wouldn't see planets or sunlight. Behind you, the solar system would be invisible, just a thought in the dark. Ahead, the Milky Way stretches across the void, a soft, endless band of light. There would be no sound, no air, no motion, only silence. You'd hear nothing but your own breathing inside the suit. The boundary of light is not just a place, it's a realization. It's the edge of our star's protection, the final breath of warmth that reaches from home. Everything we know, every tree, ocean, and heartbeat, exists within this fragile bubble of sunlight drifting through the cosmic sea. Beyond this point lies the unknown, a realm where the sun fades into the crowd of stars and light itself begins to grow tired. This is where the story of leaving truly begins. At the outermost edge of our star's reach, where human creations drift alone, and the sun becomes just another star among billions. Here, we finally start to understand the scale of what it really means to go beyond. Voyager 1, launched in 1977, is now more than 15 billion miles away. Yet in cosmic terms, it hasn't truly left home. Its faint signal, barely a whisper of energy, reminds us how tightly gravity and distance conspire to hold us close. More than 4 decades have passed since it rose from Earth's surface atop a plume of fire, carrying humanity's curiosity into the endless dark. It was built from aluminum, titanium, and hope, designed to last only 5 years. Yet it continues to travel outward, coasting through interstellar space on momentum alone, powered by the slow decay of radioactive material. Every day, it drifts another million miles farther from the sun, but the space around it remains painfully familiar, still under the faint dominion of our star. The signal it sends back to us travels at the speed of light, but even that takes more than 22 hours to arrive. By the time the data reaches our antennas, Voyager's instruments have already moved another million miles deeper into the abyss. Its messages are faint, so weak that by the time they reach Earth, the energy that left the spacecraft has spread across billions of miles of space, reduced to a power smaller than that of a snowflake hitting the ground. Yet those whispers carry everything we know about this distant realm. Through them, we've measured the boundary where the solar wind ends and the interstellar medium begins. We've listened as Voyager crossed the shock front, where particles from the sun crash into particles from the galaxy beyond. The readings changed, the hum of cosmic rays grew stronger, and then, for the first time in human history, a machine left the sun's protective bubble. Still, Voyager remains tethered to us in invisible ways. Gravity never truly lets go. The pull of the sun extends indefinitely, fading but never vanishing. Even at 15 billion miles, Voyager orbits our star, following a path that will carry it around the Milky Way for billions of years. It will never return, but it will never be entirely free. Pinned to its side is a golden record, our cosmic calling card. Etched into it are greetings in dozens of languages, the sound of ocean waves, a baby's cry, a heartbeat, a time capsule of what it meant to be human in the late 20th century. Someday, perhaps millions of years from now, another civilization might find it drifting among the stars and realize that someone else once looked up at the same cosmic sea. But for now, Voyager drifts through the emptiness, alone. The sun, once blinding, is now just a bright star among countless others. The constellations have begun to shift. Even the familiar patterns of the sky change as the spacecraft moves farther into the void. And yet, through that vast separation, a fragile thread remains, radio waves connecting a distant machine to the world that made it. Voyager 1 has travelled farther than any human creation, but it has not escaped the gravity of home. Its journey reminds us that even at the edge of the unknown, we are still orbiting the place we began. Every signal it sends back is a whisper from the frontier, a message that says, "I'm still here, and so are you." Every planet, every moon, every atom sits in the sun's deep gravitational valley. Escaping it requires unimaginable energy. Rockets roar, but gravity always waits, patient and eternal, pulling everything back toward the light. Imagine the solar system as a vast bowl, curved gently by the invisible force of gravity. The sun rests at its center, and every planet circles within its slope, trapped not by walls, but by the geometry of space itself. The deeper the bowl, the harder it is to climb out. Even Earth, floating 93 million miles away, lies far down within this cosmic well. The light that warms our oceans, the pull that keeps the moon in orbit, all of it flows from the sun's immense weight, warping the fabric of space and time around it. To escape that pull entirely, you must move faster than 42 kilometers per second, Earth's escape velocity. That's more than 150,000 kilometers per hour. Every spacecraft humanity has ever built has fought this invisible current. Rockets burn through oceans of fuel just to climb a few hundred miles above the surface, trading mass for momentum in a desperate bargain with gravity. Even once free of Earth's gravity, the sun still holds us. Every probe, every satellite, every drifting speck of human ambition remains tethered by its light. To break free completely, to escape the sun's gravity well, would take more energy than any rocket has ever produced. Even Voyager, humanity's most distant traveller, is not truly gone. It still orbits our star, just at a distance so vast that the curve of its path will take millions of years to complete. Gravity is the quiet sculptor of the cosmos. It builds galaxies, ignites stars, and holds planets in delicate balance. Without it, everything would scatter into chaos. Yet it is also the greatest obstacle to our freedom, a force that binds us to the place we were born. We can defy it for moments, but never for long. Every spacecraft that leaves Earth must surrender to its mathematics, every trajectory curved by its invisible hand. Even light itself feels gravity's touch. Near black holes, it bends and loops back on itself, unable to escape the depth of the cosmic pit. The sun's gravity is far gentler, but it still warps time and space enough that even the fastest signals slow, just slightly, as they climb away from its grasp. We are creatures of gravity. Our muscles, our bones, our hearts evolve to work within its steady pull. It shapes how we move, how we grow, even how we think. It keeps our feet on the ground, but it also keeps our dreams heavy. To reach the stars, we must first escape not only the weight of the Earth beneath us, but the deeper weight of the sun itself. The gravity well is both prison and protector, a force that binds us and gives us form. It is the reason we stand, the reason we fall, and the reason why leaving home will always demand more than fire and steel. It will demand that we overcome the oldest force we've ever known. Even if we could travel faster than any spacecraft in history, our speed would barely scratch the surface of what's required to reach another star. In the cosmic scale, human ambition moves slower than drifting dust. When we watch a rocket rise through the sky, it feels like a triumph over the impossible. The ground trembles, the clouds part, and for a few breathtaking seconds, it seems as though we've conquered gravity itself. But in truth, even our fastest machines crawl compared to the speed of light. Voyager 1, the fastest object humanity has ever launched, moves at about 17 kilometers per second, an astonishing speed by human standards. Yet it would still take over 75,000 years to reach the nearest star. We often talk about escaping the solar system, but escape is a matter of perspective. We may leave the atmosphere, break free from Earth's pull, and even drift beyond Pluto's orbit, but the sun's gravity extends for light years. To be truly free from it, a ship would need to accelerate continuously for decades. Every mile gained is another link in the chain stretched tighter by distance and time. Imagine a map of our solar system drawn to scale. The planets, once clustered in your imagination, would suddenly be separated by enormous blank spaces. Even light, the universe's fastest traveler, takes over 8 minutes to journey from the Sun to Earth, and more than 5 hours to reach Pluto. The distances between stars dwarf even that. The light from Alpha Centauri, our nearest neighbour, travels for over 4 years before it reaches us. And light doesn't rest, or refuel, or slow down. For us, time and distance multiply together into something almost insurmountable. A ship travelling at a fraction of the speed of light would still need generations to arrive. The crew's descendants would reach the destination long after Earth itself had changed, its continents shifted, its languages evolved, its civilizations forgotten. And by then, who would even remember what home once meant? Space is not an open highway. It's a slow-motion ocean where speed itself becomes meaningless. The faster we try to go, the more energy the universe demands from us in return. Doubling your speed doesn't double the energy needed, it multiplies it. The closer you approach light speed, the heavier you become, until the very laws of physics close their doors. The illusion of escape is that movement feels like freedom. But in the cosmos, motion is a trick of scale. Everything moves, yet everything remains bound. In a sense, we've already escaped as far as we can, through telescopes and data, through dreams projected onto screens, through the imagination that lets us walk among the stars without ever leaving Earth. We have sent our minds farther than our bodies could ever go. The illusion of escape reminds us of something humbling. That the universe doesn't confine us out of cruelty, but out of its own vast indifference. We are free to wander in thought, to explore in vision, but physically we remain close to home. In the end, distance is not our greatest barrier. It's our illusion that we've already overcome it. Between stars lies a desert colder than any mind can comprehend, a vacuum so perfect that even light struggles to cross it. The nearest star is 25 trillion miles away, an ocean we have only learned to stare across. This ocean has no waves, no color, no sound. It is an emptiness so vast that words like distance or space fail to describe it. Here, there is nothing to touch, nothing to hold. Each particle of matter drifts alone, separated by miles of nothingness. The density of atoms in interstellar space is so low that a single cubic meter might contain just one stray hydrogen atom. To call it a void is almost generous. It's a realm where existence itself feels stretched thin. If you could stand in the middle of this cosmic ocean and look around, the stars would seem fixed in their positions, unblinking and eternal. Yet each one lies unimaginably far away. The light you see from them left centuries, sometimes millennia ago. The stars that guide our constellations might have died long before their light reached us. In this emptiness, temperature loses its meaning. With no air to carry warmth, the only heat comes from the faint glow of distant starlight and the afterglow of the Big Bang, the cosmic microwave background. The average temperature here is just a few degrees above absolute zero, cold enough to freeze almost every atom in the universe. Even the fastest particles slow to near stillness in the endless dark. This ocean is not calm, though it appears that way. Invisible magnetic fields ripple through it, carrying charged particles from long-dead stars. Occasionally, a cosmic ray passes through, a single proton moving near the speed of light, born from a supernova half a galaxy away. These rare travelers cross the void like sparks in a bottomless sea, silent reminders that the universe is never truly still. For billions of years, this ocean has remained unchanged. It is the space between creation and destruction, the silent backdrop against which galaxies live and die. And yet, it is here that every journey beyond our solar system must begin. If we were to leave the comfort of the sun's light, this is the first frontier we would have to cross, a place with no landmarks, no destinations, and no return path once you go far enough. Scientists call it interstellar space, but poets might call it eternity. A ship traveling through it would find no air, no gravity, no sense of motion, only the gentle hum of onboard systems and the endless, unbroken dark outside. The journey would feel less like movement and more like suspension, as if time itself had slowed to a crawl. The ocean of night is not empty. It is everything between everything. It is the canvas on which the stars are painted, the dark that gives their light meaning. We are creatures of brightness, born near a star, and so the infinite night feels hostile to us. But perhaps it isn't. Perhaps it's just the universe resting, vast, silent, and waiting for someone brave enough to cross. At our fastest conceivable speed, 10% the speed of light, it would still take 40 years to reach Proxima Centauri. But to accelerate to that speed would require energy beyond the total output of our civilization. Distance, in the cosmic sense, is not just a number. It is a law, an unyielding reality written into the structure of space itself. Between us and the nearest stars lies not merely emptiness, but a scale of separation so immense that it bends the imagination. We talk about light years as casually as miles, yet a single light year is nearly 6 trillion miles. Multiply that by 4, and you begin to understand the gulf between us and our closest neighbour. Even imagining the journey is humbling. At 10% of light speed, an almost impossible feat, a starship would still crawl across the void for decades. And to get there, it would need an engine capable of producing more energy than the entire human race uses in a year, every second. Accelerating a craft to a fraction of light speed means confronting the limits of matter itself. The faster you go, the heavier you become, and the more energy you need just to keep moving. Physics itself becomes your enemy. For a traveller, the tyranny of distance is not just about how far you must go, but how much must be endured to get there. Imagine a ship coasting through the void, its engines long since shut down, its passengers suspended between stars. Outside the hull, there are no reference points, only eternal darkness and the faint, motionless glow of the Milky Way. Even at incredible speed, nothing changes for years. The destination remains a speck of light that never seems to grow closer. If we sent such a ship today, it would outlive its builders, its planners, its reason for leaving. Entire generations would live and die aboard before ever reaching another sun. Communication with Earth would take years in each direction. By the time the ship arrived, the world that launched it might have vanished, its languages forgotten, its nations erased. And that's assuming we could even start the journey. The energy required to push a vessel to 1/10 light speed is staggering, something on the scale of detonating thousands of hydrogen bombs every second for months. Even harnessing fusion, the most powerful energy source we can conceive, would barely make a dent in the requirement. Some have dreamed of using massive laser arrays to push light sails across interstellar space. Others imagine antimatter engines or black hole reactors, but every idea collides with the same wall. The distances are simply too vast, the energy too immense, the cost beyond comprehension. The tyranny of distance humbles every dream of exploration. It reminds us that the universe is not built for convenience, it's built for endurance. Time, space, and light conspire to stretch the cosmos beyond our reach. Yet this limitation is also what makes the stars beautiful. Their remoteness gives them mystery, and their distance gives us something to yearn for. In the end, the tyranny of distance may not be a punishment, it may be the universe's way of teaching patience, to remind us that the stars will always be there, waiting, even if we never arrive. It's not empty out there. The space between stars is filled with thin gas and charged particles, each atom a barrier. Over light years, they add up, eroding any ship that dares to pass. From a distance, space looks pure and silent, a perfect black canvas dotted with stars, but in truth, the void is alive with motion. Hydrogen atoms drift like cosmic dust, remnants of ancient stars that exploded long before Earth existed. These atoms, though sparse, are never still. They move at high speeds, collide, ionize, and create magnetic fields that stretch across entire regions of space. The interstellar medium is not absence, it is the faint breath of the galaxy itself. In every cubic centimeter of this vast emptiness, there may be only a few atoms, but stretch that thinness across a journey of trillions of miles, and those atoms become sandpaper against any ship that tries to pass through. At near-light speeds, a single grain of interstellar dust could strike with the force of a bullet. Larger particles, tiny pebbles of frozen carbon or silicates, would hit like bombs. A ship moving fast enough to cross the stars would need armor thicker than any we've ever built, or shields of energy powerful enough to deflect the invisible rain of particles streaming through the dark. These atoms form delicate structures that span the galaxy, wisps of hydrogen clouds, massive shock waves from ancient supernovae, and ribbons of magnetic energy weaving between stars. Our own solar system floats within one of these clouds, called the local interstellar medium, a region shaped by long-forgotten stellar explosions. Even here, on the quiet outskirts of the Milky Way, the Sun's magnetic bubble, our heliosphere, protects us from much of the interstellar storm. Beyond it, there are no such defenses. For a spacecraft leaving the solar system, crossing into this medium would be like diving into an unseen ocean. The density changes, the radiation grows harsher, and the magnetic fields twist unpredictably. Instruments aboard the Voyager probes have already detected this transition. The gentle hum of charged particles giving way to the hiss of true interstellar plasma. What was once empty becomes turbulent. If we were to send a human ship through this region, we would face a new frontier of physics and endurance. Radiation would bombard every surface, gradually eroding metal and electronics. Cosmic rays, high-energy particles from distant supernovae, would slice through walls, damaging circuits and cells alike. Even in a perfectly sealed vessel, space would still find a way to reach in. The interstellar medium is both a barrier and a record. Its particles carry the ashes of dead stars, the ingredients for new ones, and the signatures of everything that has ever burned in the galaxy. Every atom in that faint mist has been part of something, perhaps a star, perhaps a planet, perhaps a being. To move through it is to pass through history itself. We often imagine space as a void, but it is more like a sea, thin, ancient, and patient. Every wave of radiation, every drifting atom, is a reminder that even the emptiest corners of the universe are never truly empty. They're filled with memory, the residue of creation, stretching endlessly between the stars. Frictionless space might seem calm, but interstellar dust traveling at relativistic speeds becomes a storm of bullets. One grain of sand could tear through a ship like a meteor through air. In the vast emptiness between the stars, there is no atmosphere to slow you down, no friction to stop your journey. Once set in motion, a spacecraft could, in theory, glide forever. But forever is a dangerous illusion. At near-light speeds, every atom you pass becomes an obstacle. Each speck of dust, each stray molecule of gas, a high-velocity impact waiting to happen. Space is not empty. It's filled with microscopic debris, fragments of ancient comets, ash from long-dead stars, and invisible particles adrift since the galaxy's earliest days. These grains of dust, smaller than a hair's width, move through space at tens of thousands of kilometers per hour. At ordinary speeds, they pose no threat. But when a ship travels close to the speed of light, each impact carries the energy of an explosion. To strike even a single grain of dust at that velocity would be catastrophic. A pinhead-sized particle would hit with the force of a grenade. A larger fragment could puncture hulls, vaporize shielding, or destroy entire systems in an instant. In the endless dark, there would be no warning, only the silent flash of annihilation as dust meets metal at unimaginable speed. Some scientists propose protective shields, magnetic fields, plasma barriers, or thick layers of carbon composites that vaporize incoming particles before impact. Others suggest leading the ship with a thin cloud of gas or dust to absorb the first collisions, but these are only ideas. None have been tested in the conditions of true interstellar travel. Even if the ship survived, its surface would gradually erode, atom by atom. As the years unfolded, motion through the void would slowly become death by abrasion. And it's not just dust. The faster you move, the harder the universe pushes back. Every stray atom becomes a source of drag as your ship slams into them, creating shockwaves of radiation. Over time, the very act of moving fast fills your path with danger. At relativistic speeds, the forward edge of your vessel would be bombarded by high-energy particles, generating intense heat and radiation that could fry electronics or endanger anyone inside. Ironically, the faster we go, the more resistance the universe gives us. It's a cruel paradox. The frictionless void becomes more hostile as speed increases. For every kilometer per second gained, the universe answers with another layer of risk. Motion, once our greatest ally, turns into our slow undoing. In the end, the slow death of motion is not about stopping, it's about enduring. A ship moving through interstellar space would gradually be stripped by time, energy, and collisions too small to see. Decades would pass before the damage became fatal. But the end would be inevitable. The void would take back what dared to cross it. And yet, that's what makes the dream of interstellar travel so hauntingly beautiful. To move through the infinite dark, knowing that every mile traveled is both progress and decay, is the purest expression of human defiance. We are creatures that move, even when the universe reminds us that motion itself is costly. Every spark that crosses the night burns away a little more of itself, but it keeps going anyway. Even if we could move at light speed, Einstein's equations remind us that time itself bends against us. For the traveler, years might pass like moments, but for those left behind, millennia would unfold. Time is not a constant. It stretches, it bends, and it changes shape depending on how fast you move or how close you are to a source of gravity. What feels like a steady flow to us on Earth is, in truth, a fragile illusion, an agreement between motion and mass. According to relativity, the faster you go, the slower time passes for you. A traveler aboard a ship moving near light speed would live in a bubble where seconds linger longer, where aging slows, and where the universe outside seems to rush ahead. This is time dilation, one of the most haunting consequences of Einstein's theory. It means that interstellar travel would not just separate us by distance, it would separate us by time itself. Imagine a journey to a nearby star at 99% of light speed. For those on board, the trip might last only a few years. But when they return, tens of thousands of years could have passed on Earth. Civilizations would have risen and fallen, the continents would have shifted, the languages they spoke would be dust. To the traveler, it would feel like coming home after a long voyage, but to the world they left behind, they would be a relic from an ancient age, a ghost out of time. This paradox is what makes the curse of time so profound. We can imagine crossing the gulf between stars, but not crossing the centuries that unfold while we're gone. Even at our most ambitious speeds, the universe punishes movement with isolation. The faster you go, the more time you leave behind. In this way, time itself becomes the greatest distance of all. You could leave Earth and never truly return, not because of how far you've gone, but because your home will no longer exist in the same moment as you. Every second of acceleration would stretch the gap wider until both traveler and home drift into separate timelines of the same universe. And for those who stay behind, the stars would tell a different story. They would watch the traveler's ship vanish into darkness, its light fading until it becomes just another star in the sky. They would grow old, their descendants looking up at that same point of light, not knowing that inside it, time is almost standing still. The curse of time reminds us that space travel is not only about distance, it's about sacrifice. To chase the stars might mean giving up the world that sent you. To return might mean finding it gone. Perhaps that's why, deep down, we hesitate to go. Because leaving the solar system is not just leaving home, it's leaving our own moment in history. The universe allows us to move through space, but never without a cost. For every mile gained, another second is lost. And time always wins in the end. Our spacecraft send back whispers measured in billionths of a watt. As they drift farther, their messages fade into static, swallowed by cosmic background noise, the hum of creation itself. Every probe we've ever sent into the deep has carried with it a fragile thread of communication. A narrow beam of radio light stretching across billions of miles. Those faint transmissions are the only voices we have in the void. A few watts of power, sent across a sea so immense that by the time it reaches Earth, it's weaker than the flicker of a single candle seen from the moon. When Voyager 1 sends a signal, it begins as a pulse from a dish barely the size of a small room. That pulse travels at light speed, crossing planets, moons, and the faint breath of the solar wind. By the time it reaches Earth, more than 15 billion miles away, it has scattered and weakened until it arrives as a signal so faint that it takes the largest radio antennas on the planet to catch it. The Deep Space Network, a series of massive dishes in California, Spain, and Australia, listens constantly, ears pressed to the edge of the universe, straining to hear that fading voice. Each transmission carries a story. Readings of charged particles, the density of space, the temperature of interstellar gas. They are postcards from the frontier, written in binary code. But as the distance grows, so does the silence. Space is not empty. It's filled with radiation, with the background hum left over from the birth of the universe. This cosmic static drowns out the fragile murmur of our machines. The farther a probe drifts, the weaker its power becomes. The plutonium that fuels Voyager's instruments decays a little more each year. Its sensors are slowly shutting down to save energy. One by one, the lights go out. Eventually, the transmitter will fall silent, the last signal fading into a background that has existed since time began. When that moment comes, Voyager will continue to drift, mute, cold, but still moving, carrying the golden record with its greetings, its music, its heartbeat of humanity. somewhere in that silence will be the echo of who we were. The fading signal is more than a technical limit, it's a metaphor for our place in the cosmos. No matter how far we reach, communication is always delayed, always weaker, always at the mercy of distance. Every signal is an act of faith, a belief that someone, somewhere, is still listening. It's humbling to think that even the strongest transmissions humanity has ever produced eventually dissolve into the noise of the universe. Somewhere beyond Neptune, our messages scatter into infinity, merging with the ancient radiation of the Big Bang. Perhaps that's the fate of all our voices, to become part of the cosmic background, indistinguishable from the hum that has echoed since creation. Yet, in that thought, there's something profoundly beautiful, because even when our signals fade, they never truly disappear. They become part of the universe's eternal song, a faint human harmony woven into the silence of forever. Voyager's power comes from decaying plutonium, its warmth fading year by year. One day soon, it will fall silent, drifting forever between the stars, a message in a bottle that no one may ever find. For nearly half a century, Voyager 1 and its twin, Voyager 2, have been the farthest travelers humanity has ever known. Each one carries a tiny heart of heat, a nuclear battery that converts the decay of plutonium into electricity. It's not much, just a few hundred watts, but enough to power their instruments, their cameras, and their voices. Every year, that warmth lessens, the current weakens, and one by one, their systems are shut down. Cameras have gone dark, instruments have gone quiet. Soon, the transmitters will follow, and the two Voyagers will be left in complete silence, cold machines gliding through an eternal night. Even now, as they drift beyond the sun's protective reach, they continue to send us data. The whisper of charged particles, the hiss of interstellar plasma, the faint beat of the cosmic sea. These readings are the last sensory impressions of our solar system's outer edge. They are the final words of a civilization calling back from the threshold of forever. When the last generator fails, the spacecraft will no longer speak. The warmth from the plutonium will still exist, but only as a ghost, fading heat radiating into space. The machines will become nothing more than silent messengers, their golden records gleaming in the dark, each one etched with the sounds of Earth. Rain, thunder, laughter, the song of a mother to her child. It's a haunting thought that someday, perhaps 1 billion years from now, another civilization might find them. By then, Earth may be unrecognizable. Our continents shifted, our species changed, our cities long gone. Yet those golden discs would still spin in the dark, carrying our greetings in 55 languages, our music, our dreams. In the end, these cold machines might outlive everything that sent them. But even if no one ever finds them, the Voyagers will still serve a purpose. They remind us of what it means to reach beyond comfort, beyond lifespan, beyond meaning. They are monuments not of technology, but of hope. In their silence, they carry proof that we once looked outward with wonder. Their journey will continue long after our sun dies. For the next 1 billion years, they'll orbit the Milky Way, passing between stars, through clouds of dust and radiation, untouched and unseen. Their metal will slowly corrode under cosmic rays, their records will blur, but their trajectory will remain, etched into the gravity of the galaxy itself. The cold machines are more than explorers. They are our legacy cast into the ocean of night. Each one a reminder that even in the face of infinite silence, humanity found the courage to speak, to send a message into the dark, knowing it might never be heard. And maybe that's what makes them so profoundly human. Not the technology, not the data, but the act of reaching out into the endless dark, whispering into eternity, and believing that someone, somewhere, might someday listen. Nothing with mass can reach the speed of light. It isn't just a limit, it's the law of reality. As velocity increases, mass grows, time slows, and energy demands approach infinity. In the universe, Light is the ultimate sprinter. It moves at a speed of nearly 300,000 kilometers per second, fast enough to circle Earth 7 times in a single heartbeat. Every photon that leaves the sun travels this cosmic speed limit without slowing, carrying warmth and information across the vastness of space. But for everything else, planets, ships, people, this limit is absolute. To reach it is to demand the impossible. The closer an object gets to light speed, the heavier it becomes. Its mass, according to Einstein's equations, begins to increase without bound. The faster you go, the more energy you need to keep accelerating. At half the speed of light, the energy demand is staggering. At 99%, it becomes nearly infinite. To push even a small spacecraft to such speed would require more energy than all the stars in our galaxy emit in a second. Light speed isn't just a number, it's a wall built into the very fabric of the universe. It defines what is possible and what is not. For photons, this barrier is no obstacle. They are born at the limit and can never go slower. But for anything with mass, the speed of light is a horizon that can only be approached, never crossed. It's the cosmic finish line that always moves just out of reach. Time itself begins to warp near this boundary. The faster you move, the slower your clock ticks compared to those at rest. To a traveler nearing light speed, seconds stretch and the outside universe races ahead. Distance shrinks, and centuries could pass beyond the ship, while only moments unfold inside it. This strange effect makes high-speed travel a journey not just through space, but through time itself. Yet even if we could endure the physical limits, the energy costs alone would halt us. Propulsion becomes a paradox. As your mass increases, you need more thrust. As you add more energy, your fuel becomes heavier, making the problem worse. No engine, no matter how advanced, can escape this cycle. Fusion, antimatter, even hypothetical warp drives must still obey the same law. Nothing with mass can ever truly reach light speed. And so, the universe enforces its quiet boundary. Stars may move, galaxies may collide, but the speed of light remains constant, a ruler by which all motion is measured. It is the universe's way of maintaining order, of keeping cause and effect in balance. To us, this law feels like a cage. But perhaps it's also a gift. If nothing could outrun light, then information, reality, and existence itself would unravel. The speed limit keeps time coherent, the cosmos stable, and life possible. It is not a punishment, it is the structure that allows the universe to make sense. Still, when we gaze up at the stars, we can't help but feel the ache of that barrier. Light may be the messenger of the cosmos, but it's also the reminder that we will always follow behind it, chasing a horizon that forever recedes. Light itself is both messenger and barrier. It reveals the universe to us, but also shows us how vast it truly is. The same photons that let us see the stars remind us we'll never reach them. Every night, when we look up at the sky, we are bathing in ancient light. The glow from distant stars and galaxies is not what they are now, but what they once were, echoes travelling across cosmic time. Some of the light striking your eyes tonight left its source before humanity even existed. Each photon carries a story from the past, moving through the void at the universe's highest speed, a courier that can never slow down or rest. It's easy to think of light as simple illumination, but it's far more than that. It's our only bridge to the universe beyond. We use it to map galaxies, to measure time, to understand everything that lies past our reach. Without light, we would live in total ignorance of the cosmos. But with it, we are forever reminded of how distant everything truly is. For even as light connects us, it also defines the limits of connection. Nothing can reach us faster than it travels, and so everything we see is already history. When we gaze at a nearby star, we are seeing it as it was years ago. When we look at the Andromeda galaxy, we're looking back more than 2 million years. When we peer at the faintest galaxies at the edge of the observable universe, we're seeing light that began its journey over 13 billion years ago, nearly to the beginning of time itself. The farther we look, the further back we go. This is the paradox. Light gives us sight, but denies us immediacy. It reveals beauty while concealing the present. The image of the universe we see is a portrait painted in delay, a silent museum of moments long gone. The light we receive from distant worlds might be all that remains of them. Stars die, galaxies collide, and yet their light continues to travel, carrying their memory across eternity. Even in our solar system, light reminds us of its limits. The sun's warmth takes over 8 minutes to reach Earth. That means when you watch a sunrise, you are seeing the sun as it was 8 minutes ago. For the outer planets, the delay stretches into hours. For the nearest stars, into years. If an alien civilization looked at Earth right now from 10 light years away, they would see a version of our planet from 2015, a time capsule of our past, not our present. And so, every beam of light is both revelation and restraint. It gives us the ability to understand the cosmos, but also shows us that we are locked inside a universe where instant knowledge is impossible. Even the fastest thing in existence carries delay, distortion, and distance. Perhaps that's the beauty of it. Light reminds us that the universe doesn't exist for our convenience. It exists in its own time, at its own pace. We are forever catching up to it, forever reading the messages it sends from the past. In the end, the paradox of light is what keeps the cosmos wondrous. Because if we could see everything as it is, all at once, there would be no mystery, no yearning, no awe. The stars would lose their magic. It is the delay, the distance, that gives them their eternal glow. Our solar system is a tiny bubble inside the local interstellar cloud, a mist of gas left from ancient supernovae. To leave this cloud is to step beyond the material legacy of our own birth. Though space seems empty, we are surrounded by invisible structure, filaments of dust, gas, and magnetism that shape the galaxy like the veins of a living organism. The sun and its planets drift together through a soft, ghostly fog of hydrogen and helium known as the local interstellar cloud. It's a region about 30 light-years across, moving through the galaxy at nearly 50,000 miles per hour. And we are just passengers inside it, floating through the debris of ancient stars that once burned, exploded, and gave rise to everything we know. This cloud, delicate and diffuse, is the material residue of creation. Long ago, nearby stars reached the end of their lives in violent supernovae, scattering their elements into space, carbon, oxygen, nitrogen, iron. These became the raw ingredients of new worlds, new suns, and eventually, us. The local interstellar cloud is the smoke left behind from that cosmic fire. And now, our solar system sails through it, gathering traces of our own origin as we go. The heliosphere, the bubble formed by the solar wind, acts like a protective shield, pushing back against this interstellar fog. It's what keeps most of the charged particles from the cloud from entering our planetary space. At its boundary, the sun's influence fades, and the gas and dust of the galaxy begin to mingle with the edge of our home. It's there that Voyager 1 and 2 have now crossed, our first emissaries into the true interstellar medium. Scientists estimate that in the next few tens of thousands of years, our solar system will drift out of the local cloud entirely, entering a new region of the galaxy with different densities, pressures, and magnetic conditions. To cross from one cloud to another may not sound dramatic, but on a cosmic scale, it's like sailing from one ocean into another, uncharted, unpredictable, and potentially transformative. What's fascinating is that these clouds are not static. They flow, merge, and shift through the Milky Way, carried along by the gravitational tides of stars and dark matter. The galaxy itself is a giant ecosystem, with clouds forming stars, stars creating elements, and those elements feeding back into new clouds once more. Every breath of interstellar gas is part of this eternal cycle. The local interstellar cloud reminds us that even our corner of the universe is not isolated. We are connected, materially and historically, to stars that lived and died millions of years before the sun ever ignited. The atoms in your body, your bones, your blood, the air you breathe, were forged in those explosions. The same elements drifting in this cloud once belonged to the hearts of long-dead suns. And so, our solar system's cosmic neighborhood isn't just a location, it's a lineage. A heritage of matter passed from star to star, from death to rebirth. To leave the local interstellar cloud one day will mean leaving the remnants of our ancestors, the stellar dust that once became us. It's humbling to realize that even in the emptiness of interstellar space, we are surrounded by memory. The galaxy is a vast archive of everything that has ever burned, fallen, and begun again. We don't just live in the Milky Way, we are made of it. Far beyond the heliosphere lies a realm without warmth. Here, temperatures fall to near absolute zero. Any journey through it would mean endless cold, where even starlight can't offer comfort. In this place, heat becomes a memory. The warmth of the sun, the gentle radiation that gives life to our planet, fades into nothing. The temperature of interstellar space hovers just a few degrees above absolute zero, about minus 270 degrees Celsius. It is a cold so deep that even atoms barely move. Molecules freeze, metals become brittle, and the familiar hum of energy that fills our world falls silent. If you could drift here, far beyond the sun's reach, you would find yourself in a vast and motionless sea. The nearest star would shine only as a distant glimmer, its light too faint to warm even the skin of a ship. The darkness would seem infinite, so black that it almost feels heavy. No wind, no sound, no sense of direction. This is the interstellar winter, the deep freeze that lies between stars. It is not hostile in the way deserts or oceans are. It doesn't rage or roar. Its danger is its stillness. In this void, heat leaks away into eternity, and nothing returns. Even the smallest loss of warmth becomes permanent. For a spacecraft, that means every watt of energy is precious. Every system must sip power carefully. Every particle of heat must be recycled or lost forever. The cold shapes everything that dares to travel here. Lubricants freeze solid, metals contract, electronics behave unpredictably. Even radiation shields, designed to protect against high-energy particles, become brittle with time. The interstellar winter tests not only technology, but endurance itself. Survival here is not about strength, but about balance, maintaining just enough energy to keep the dark at bay without running out of it completely. Yet there's a strange beauty in this frozen vastness. The same cold that threatens to extinguish life also preserves it. Objects adrift in the interstellar deep can remain unchanged for eons. Comets, dust grains, fragments of forgotten worlds all sleep here, locked in ice, waiting for the faint pull of gravity to wake them again. The universe's cold storage. And somewhere, beyond our perception, the light of distant stars travels through this chill unhindered. Every photon that crosses the void carries with it a piece of warmth from another sun, a reminder that even in the coldest corners, light still moves. The interstellar winter is not an end, it's the quiet between acts. The space between one creation and the next. It's where the ashes of old stars mix with the seeds of new ones, waiting in the cold until gravity stirs them to life again. For any future travelers, this is the reality they would face. A voyage through eternity's night, wrapped in silence, surrounded by ice, guided only by faith and faint starlight. It is the purest expression of isolation imaginable, and yet, perhaps, also the most peaceful. In the interstellar winter, the universe rests. It is not cruel or unwelcoming, it is simply still. And in that stillness, there is both danger and serenity. Every kilogram launched into space demands oceans of fuel. The farther we go, the more energy we must carry, until the mass of the ship collapses under its own ambition. Escaping Earth isn't just a challenge, it's an equation written in fire. To break free from our planet's pull, a rocket must accelerate to over 11 kilometers per second. That means every gram of cargo, every bolt, every drop of fuel must fight against the invisible grip of gravity. The more fuel you add to push farther, the heavier your ship becomes, and the heavier it becomes, the more fuel you need. It's a spiral that punishes ambition. This is known as the tyranny of the rocket equation, a cruel but simple law that governs all space travel. The energy required to reach orbit is enormous, but to leave the solar system entirely is exponentially greater. Each stage of a rocket must carry not only its payload but also the fuel for the next stage and the next after that. The deeper you plan to go, the more mass you must haul, until the dream of escape buckles beneath its own weight. Even today's most powerful rockets, like SpaceX's Starship or NASA's Space Launch System, can only send modest payloads beyond Earth's gravity. The Voyager probes, our most distant emissaries, were tiny, each weighing less than a family car, and still needed a planetary slingshot from Jupiter to reach interstellar space. For a human ship, with life support, shielding, and supplies for decades, the numbers quickly become impossible. Consider this. To reach even 1/10 the speed of light, a craft the size of a small shuttle would require energy equivalent to the total output of the human race for centuries. The fuel alone would outweigh mountains. Nuclear propulsion could help, but even then, the logistics border on the absurd. Carrying enough material to feed a fusion reactor for a journey spanning decades would make the ship a floating fortress of fuel, a star in miniature. And that's only the energy needed to accelerate. Once in motion, the ship must also slow down at its destination. To decelerate safely, it would need just as much energy in reverse. There's no air to brake against, no planetary atmosphere to help. Momentum becomes another trap. Once you commit to the void, stopping becomes as hard as starting. So every plan to leave, every interstellar concept, every generational arc, every theoretical light sail, faces the same truth. Movement costs energy, and in space, there are no shortcuts. There's no refueling station, no natural pit stop between stars. You must take everything with you, and every bit of what you take slows you down. The cost of leaving isn't only measured in fuel or energy, it's measured in what we must give up. Comfort, safety, time, even connection. The farther we go, the less we can bring, and the more we must sacrifice to keep moving. And yet, knowing this, we still build, still dream, still launch. Because leaving has never been just about reaching another place. It's about proving that we can. The cost of leaving may be steep, but for humanity, the price of staying still has always felt even higher. There are no landmarks in deep space, no north or south, no up or down. A ship leaving the solar system would travel blind, guided only by the faint pull of distant stars. Beyond the orbit of Neptune, the familiar fades quickly. The sun becomes a pale dot in an endless black ocean, and the constellations, once steady guides in Earth's night sky, lose their shape as perspective shifts. The great hunter Orion, the bright arc of the Big Dipper, all begin to warp and twist. Without a fixed frame of reference, direction itself becomes meaningless. There are no coastlines to follow, no mountains to orient by, only the slow drift of starlight across the void. In this frontier, navigation becomes an act of faith. Spacecraft must rely on distant pulsars, neutron stars spinning with incredible precision, whose rhythmic beams of radiation serve as cosmic lighthouses. Their signals can be measured, triangulated, and used to estimate position. But even these methods provide only rough bearings in a sea too vast for certainty. One small miscalculation, one fraction of a degree off course, and a traveller could drift endlessly between stars, never nearing anything, never turning back. It's easy to imagine the silence of such a voyage. No radio chatter, no background hum of atmosphere, no sound at all. Only the faint vibrations of the ship itself, the creak of metal cooling, the whisper of circulating air, the heartbeat of systems running on borrowed time. The vacuum absorbs all noise, all sensation, all feeling of movement. The illusion of stillness becomes overwhelming, even as the ship speeds through space at thousands of kilometers per second. This silence isn't just physical, it's existential. On Earth, sound connects us. The rustle of leaves, the call of a bird, the echo of a voice, they all remind us we're not alone. In deep space, silence becomes the only companion. It's so complete that even one's own breathing would seem deafening, a rhythmic reminder of life in a place that has none. To journey into the silent frontier is to enter a realm that has no beginning or end, only directionless distance. A ship venturing beyond our solar system would not see its destination. It would simply move forward, guided by instruments, drifting between invisible tides of gravity and light. Navigation becomes meditation, an act of constant calculation and quiet trust. And yet, in that emptiness, there is beauty. Without atmosphere, stars no longer twinkle. They burn steady and sharp, piercing through the void with perfect clarity. Nebulas glow like stained glass in the distance, their colors untouched by distortion. Even darkness itself feels pure, almost sacred. The silent frontier is not chaos, it is calm. It is the universe stripped to its essence, motion, gravity, and light. For all its danger and isolation, it offers something no other place can, the purest sense of scale. It reminds us how small we are, how quiet the cosmos truly is, and how miraculous it is that life, in all its noise and warmth, ever found a voice here at all. To cross the silent frontier is to surrender to that vast stillness, to travel not in conquest, but in humility. Listening for meaning in a place where none exists, and perhaps finding it within ourselves. Our bodies are designed for Earth's gentle pull and breathable air. In the emptiness between stars, radiation, isolation, and time itself become predators. Evolution tied us to one planet, and it may not let us go. Every part of us, from the calcium in our bones to the iron in our blood, was shaped by Earth. We are the children of its gravity, its pressure, its rhythms. Our muscles depend on its pull. Our hearts beat in time with its rotation. Our minds evolved under its sky, guided by the rise and fall of the sun. To leave that behind is not just to step into another environment. It's to defy the very conditions that made us possible. In microgravity, even the strongest body begins to unravel. Muscles weaken, bones dissolve, and blood redistributes toward the head, confusing the brain's sense of direction. Astronauts who spend months on the International Space Station must exercise for hours every day just to slow the decay. And yet, even with all our precautions, the body still forgets the feeling of weight. If a journey to another star were to take decades or centuries, the biological toll would be profound. Without gravity, our physiology would slowly rewrite itself into something unrecognizable. Then there's radiation, the invisible enemy of space. Beyond the magnetic shield of the Earth and Sun, cosmic rays bombard everything unprotected. These are high-energy particles from distant supernovae, capable of tearing through DNA, damaging cells, and accelerating aging. On a trip lasting generations, such radiation would cause cancers, genetic mutations, and cognitive decline. Even the best shielding humanity could build might not block it completely. And what of the mind? In the vastness of interstellar travel, isolation becomes its own form of gravity. The silence, the sameness, the endless stretch of time, all would press upon the psyche. On long missions, astronauts already report hallucinations, anxiety, and the strange feeling of Earth hunger. A deep, instinctual yearning for open air, sunlight, and living ecosystems. Imagine that stretched over a lifetime, with no real horizon, no seasons, no sound of wind or rain. Even if we solved every technological challenge, biology would remain the hardest to overcome. We are not built for eternity. We are built for cycles, for birth, growth, decay, and renewal. A journey between stars would demand a biology that can endure timelessness. It might require altering ourselves at the genetic level, creating humans that can hibernate for decades, resist radiation, or live within artificial gravity. But would such beings still be human as we know it, Or would evolution have quietly replaced us with something else, something built for the void? There's a quiet truth hidden in this challenge. We don't just carry our bodies into space, we carry our dependence on home. Earth isn't just where we live, it's part of who we are. The pull of its gravity, the mix of its air, the taste of its water, these are not luxuries. They're the blueprint of life itself. To travel beyond the solar system would mean leaving not only the planet, but the biology that ties us to it. The boundaries of biology are the boundaries of belonging. To cross them would be to shed what it means to be earthborn. Perhaps one day we will. But for now, we remain what we have always been, creatures of a single world, breathing the air of our ancestors, tethered to a planet that made us in its image. To reach another star at sublight speeds would take generations. Crews would live and die without ever seeing their destination. Whole civilizations could rise and fall before arrival. Time, in the vastness of interstellar space, is not just a measure, it is an obstacle. When distances are counted in trillions of miles, the years stretch into centuries, and the centuries into eras. Even at speeds far beyond anything we can achieve today, a ship bound for another star would drift through a silence that outlasts human memory. The mission would become more than a journey, it would become a lineage. The idea of a generation ship, an enormous self-sustaining world travelling between stars, has long haunted science fiction and scientific thought alike. Inside, entire societies would form, children born knowing nothing but the hum of engines, the glow of artificial sunlight, and stories of a planet they've never seen. Their grandparents would have been the pioneers, their descendants would be the ones to arrive. Life on such a vessel would mean growing up in motion, yet feeling completely still, a world without seasons, without night skies, where time itself feels endless and circular. But the weight of time would not only test patience, it would erode purpose. How do you inspire meaning in generations born not to explore, but simply to continue? History fades quickly, and without constant renewal, stories become myth. By the 10th or 20th generation, the original goal of the mission could be forgotten entirely. The ship could turn inward, its people preoccupied with survival, culture, and conflict, repeating the rise and fall of civilizations inside a steel cocoon adrift in the dark. Even communication with Earth would be impossible in any meaningful sense. By the time a message from the ship arrived, centuries could have passed on both ends. Earth itself might no longer exist, or may have evolved into something unrecognizable. There's also the quiet physical toll of time. Machines break, materials degrade, radiation slowly seeps through every barrier. A system meant to last decades might endure, but can it last millennia? Even self-repairing systems would face entropy, the universal rule that all things decay. The ship's structure, its power sources, its ecosystems would need to be endlessly maintained or gradually replaced. And all of this would fall to generations that never agreed to the mission, they were born into it. Perhaps that's the most haunting part. Not the distance, not the physics, but the human cost. A ship that travels for hundreds of years becomes a moving monument to endurance. Its passengers live knowing their entire existence is just a bridge between departure and arrival, a life spent in service of a dream meant for someone else. The weight of time is heavier than gravity, stronger than isolation. It presses down not on the body, but on the spirit. It reminds us that our species, though curious and brave, is still bound to the scale of its own lifetime. To cross the stars, we would need to break more than the laws of physics. We would need to break free from the rhythm of life itself. Because even if a ship could survive the journey, would its people still remember why they left? Or would they, like so many before them, look out into the dark and realize that the true destination was never the stars, but the memory of home they left behind? Fusion power could, in theory, take us to another system, but only if we could harness it with perfect efficiency. Even then, the voyage would drain the resources of an entire world. Every dream of interstellar travel eventually collides with the same brutal arithmetic. energy. Moving through space at a fraction of light speed demands a level of power so enormous that it dwarfs every engine, reactor, and generator humanity has ever built. The faster we want to go, the greater the price. The energy equation doesn't care about ambition or courage. It only balances what's possible against what's available. Rocket fuel, in its chemical form, was never meant for the stars. The engines that carried us to the moon released massive amounts of power, but even those titanic bursts are nothing compared to what's required for the distances between stars. At best, chemical rockets can achieve speeds of a few tens of kilometers per second, a crawl against the cosmic scale. To go further, we must think bigger, deeper, more elemental. That's where fusion comes in, the process that powers the sun itself. When hydrogen atoms fuse to form helium, they release tremendous energy. Controlled fusion could, in theory, give a spacecraft a continuous push, accelerating it for years. It's the holy grail of propulsion, clean, efficient, and capable of sustaining a journey that spans light years. But theory is a generous word. After nearly a century of trying, we have yet to achieve a sustained net positive fusion reaction even here on Earth, under controlled conditions. The stars make it look easy. Let's imagine, though, that we succeed. Suppose we build a ship that can ignite fusion reactions, turning a fraction of its mass into thrust. Even then, the math is punishing. To propel a ship the size of a small city to even a tenth of light speed, it would need fuel equal to billions of tons of hydrogen, more than we could ever harvest from our planet's oceans. Gathering that much mass, compressing it, storing it, and controlling it safely would take not one civilization, but the effort of an entire species unified for centuries. Then comes another cruel reality. Efficiency. Even fusion isn't perfect. Energy is lost in heat, in containment, in radiation that can't be redirected. A ship might use 90% of its fuel just to carry the rest of it, leaving only a fraction for acceleration and deceleration. The faster we try to go, the less practical it becomes. The universe, it seems, does not reward impatience. There are other ideas, of course. Antimatter, propulsion, solar sails, or tapping into the fabric of space-time itself. But all of them face the same truth. Power is finite, and distance is infinite. The scales of the cosmos are so vast that even our grandest energies become microscopic against them. The energy equation is not just a technical challenge, it's a mirror reflecting our limitations. It reminds us that motion through space is not free, that every bit of progress demands sacrifice. To cross the stars, we would need to spend not just fuel, but the very wealth of our world. Perhaps one day we'll find a new kind of energy, a way to bend space rather than cross it. But until then, the energy equation stands as the gatekeeper of the stars. It asks a simple question of every would-be traveler: how much are you willing to give for the chance to go? Even if we made it to another star, the distance would make communication impossible. Every word, every signal would take decades to arrive. Exploration would become exile. To reach another star is to cross not only the void of space, but the void of time. The farther we go, the slower our voices become. Light speed, our ultimate limit, turns from freedom to constraint. A message sent from a nearby star would take 4 years to reach Earth, and another 4 for a reply to return. The conversation would span nearly a decade. There would be no dialogue, only echoes, faint signals lost in the static of cosmic background noise. In the early days of exploration, every journey assumed the hope of coming home. Once a ship leaves the solar system behind, the idea of home begins to dissolve. The distances are too great, the delays too long, the energy too immense. The universe doesn't just separate us by space, it isolates us through time. Imagine standing on a planet orbiting another star, perhaps one with blue skies and unfamiliar constellations. You set up a transmitter, send your first message back to Earth: we made it, we're alive. Then you wait. 4 years pass before anyone even receives your words. 4 more before their reply reaches you. 8 years to complete a single exchange, a conversation stretched across generations. The speed of light becomes the slowest thing you know. In that silence, the meaning of explorer changes. Exploration, in human history, has always been tethered to communication, to maps, reports, and the return of knowledge. But on interstellar scales, there is no feedback loop, no guidance, no confirmation. Once you leave, you vanish into history. You become a myth, someone who may have lived, but who cannot be reached. Even if the mission succeeded, what would success mean? The crew, or their descendants, might find a new world and send back proof, a few images, some data, maybe even a recorded voice. But by the time those signals reached Earth, civilizations might have changed, languages evolved, nations disappeared. The people waiting for those words might no longer exist. The explorers would be sending messages to a future that has forgotten them. And then there's the physical impossibility of return. A ship that travels light years away would need as much energy to come back as it took to leave. Without vast refueling infrastructure, something we can't yet imagine, the journey home would remain a dream. The travelers would live and die among the stars, their descendants knowing Earth only as a legend. In that way, exploration becomes exile, not out of punishment, but necessity. The first humans to truly leave the solar system would not be adventurers coming back with stories. They would be pilgrims, walking a one-way path into the infinite. Their journey would be an act of faith, not expectation. And yet, perhaps that's the ultimate expression of human courage, to step so far from home that return no longer matters. To explore not for the sake of coming back, but for the sake of knowing that someone once dared to go. In the silence between stars, where words fade and distant swallows all sound, we would learn the truest meaning of exploration. That discovery is not always about finding something new, it's about learning what we're willing to leave behind. Beyond the magnetic cocoon of the sun, radiation from ancient supernovae streams through space like invisible knives. To cross the void, we'd need shields thicker than any rocket could bear. In the deep reaches beyond the heliosphere, space becomes an ocean of unseen danger. The solar wind, which once protected us like a gentle magnetic tide, fades into silence. In its place comes a torrent of high-energy particles, protons, atomic nuclei, and cosmic rays born from the deaths of stars. These are the ashes of supernovae, accelerated across the galaxy by magnetic fields and shockwaves. Each particle carries an energy so immense that it can tear through metal, electronics, and flesh alike. On Earth, we are wrapped in layers of safety. Our planet's magnetic field and atmosphere absorb these cosmic bullets long before they reach us. Even in orbit, astronauts aboard the International Space Station are still mostly protected by Earth's invisible shield. But once you step beyond that magnetic umbrella, you enter a shooting gallery of radiation, where protection is a matter of survival. A single cosmic ray can pass through a spacecraft, slicing through atoms, knocking electrons loose, and triggering radiation cascades that damage everything in their path. For electronics, it can mean system failure. For living tissue, it can mean cancer, DNA damage, or fatal radiation sickness. Over the course of a multi-decade interstellar journey, exposure to these particles would be relentless and cumulative, a slow, invisible storm that never ends. To defend against it, we'd need shielding. But here lies another paradox. The best protection against radiation is mass, thick layers of metal, water, or hydrogen-rich materials. Yet the more shielding you add, the heavier the spacecraft becomes. And the heavier it becomes, the more fuel and energy are needed to propel it. The very act of protecting the crew makes it harder to travel at all. It's a trade-off with no easy solution. Some have imagined ships wrapped in electromagnetic bubbles, artificial magnetospheres that could deflect charged particles just as Earth's field does. Others propose surrounding the crew compartments with vast tanks of water or even ice, turning their own life support systems into armor. There's even talk of using plasma fields, generated by superconducting coils, to repel radiation. But all of these ideas remain theoretical, untested in the true conditions of deep space. Even with shielding, radiation finds ways to seep through. Cosmic rays are so energetic that they can fragment the very atoms in a spacecraft's hull, producing secondary particles that are sometimes even more dangerous than the originals. It's like trying to stop a flood by building a dam out of mist. For humans, the danger goes beyond biology. It reaches into psychology. Living under the constant awareness of invisible radiation, with no sense of safety, would erode even the strongest mind. Every flicker on a monitor, every glitch in a sensor, could feel like a reminder of mortality. And yet, this same radiation tells a story. It is evidence of a living galaxy, of stars that burned, died, and scattered their elements across the cosmos. The carbon in our bones, the iron in our blood, the gold in our jewelry, all were born in the same explosions that now threaten us. The danger and the beauty come from the same source. The cosmic radiation reminds us that the universe is both our parent and our predator. It forged us in fire, then cast us into the dark, daring us to survive in the world it left behind. To cross the interstellar void is to walk once more into the forge that made us, and to learn whether we are strong enough to endure its light. A true interstellar craft would have to be self-sustaining, a moving planet with its own ecosystems and gravity. When we imagine starships, we often picture sleek metal vessels gliding through the void, engines glowing blue, their passengers staring out at the cosmos. But the reality of interstellar travel would be far less cinematic. A ship capable of surviving centuries among the stars would have to be more than a vehicle. It would have to be a world. Everything about such a ship would defy our current scale of engineering. It couldn't simply carry supplies. It would need to grow them. It couldn't just recycle oxygen and water. It would need to produce them in self-sustaining cycles. Its inhabitants wouldn't be passengers. They would be citizens of a miniature ecosystem orbiting a distant star that never moves. This vessel would have to simulate gravity, regulate temperature, control radiation, and sustain life indefinitely, without ever depending on help from home. Inside, it might look more like a small Earth than a spacecraft. Fields of crops growing under artificial suns, rivers of recycled water winding through corridors of metal and glass. Forests engineered not for beauty, but for balance, for oxygen, humidity, and soil renewal. Cities built into the ship's structure, their lights forming constellations of their own. Generations would live and die inside this sealed biosphere, their lives governed not by sunrise or sunset, but by the steady hum of reactors and the rhythm of artificial day. To create gravity, the ship might need to spin, its outer ring rotating to mimic the pull of Earth. But that spin would have to be precise. Too fast, and it would tear itself apart. Too slow, and its inhabitants would float endlessly, their muscles wasting away. Every system would require constant maintenance, every detail perfectly calibrated, every ecosystem delicately balanced. And then there's the energy. A world-sized ship would demand power on a planetary scale, nuclear fusion reactors, antimatter engines, or technologies not yet imagined. It would need propulsion not just for acceleration, but for decades or centuries of continuous operation. Even slowing down at its destination would require unimaginable energy. The human challenge would be just as great. On a ship that large, society itself would have to evolve. People would need governments, traditions, and purpose. Children would grow up never seeing an open sky, their concept of home defined by walls of metal and the gentle curve of artificial gravity. The mission that launched their ancestors would become mythology, a story passed down through generations until the reason for their journey became almost sacred. In essence, the ship would become a civilization adrift, a world within a world. Its people would live, work, and die beneath a ceiling of stars they could never reach, moving through the darkness not as explorers, but as stewards of a fragile ecosystem sustained by their own discipline. And maybe that's what the future of space travel will truly look like. Not small crews on fast ships, but vast habitats carrying the memory of Earth wherever they go. Planets of steel and light drifting through the cosmos as ambassadors of life. Because to cross the stars, we won't just need ships. We'll need worlds. Worlds that remember where they came from. Worlds that carry the heartbeat of Earth into the deep. Worlds that remind the universe that, once upon a time, something living dared to travel between the stars. Science fiction dreams of ships where generations live and die en route to other suns, but human memory fades. By arrival, the descendants may have forgotten why they left. The generational arc is one of humanity's most haunting and poetic ideas, a vessel so large, so self-sufficient, that it could carry not just a crew, but a civilization across the gulf of time and space. Inside its walls, families would be born, grow old, and die, their children inheriting both the stars above them and the mission that gave their lives meaning. But what begins as exploration might end as something very different. A slow transformation of purpose, identity, and belief. Imagine such a ship centuries into its voyage. The original explorers, the ones who felt the tremor of launch, who saw Earth shrink into a pale blue memory, are long gone. Their children, and their children's children, know only the ship's corridors, the hum of its engines, the artificial dawn and dusk of its recycled light. To them, Earth is a story told in the quiet hours before sleep. Its oceans and skies are myths. Its gravity a legend. Over generations, purpose blurs. What was once a mission becomes tradition. What was once tradition becomes ritual. People begin to question the old stories. Some might see the ship not as a vessel in motion, but as the universe itself, the only world they've ever known. The idea of a destination may sound as impossible as the idea of a creator once sounded to us. The stars beyond the hull could come to represent mystery or danger, not hope. Sociologists and writers have long speculated about this. Without constant contact with Earth, without a reminder of who they are and where they came from, a generational crew could lose all sense of their mission. After a few centuries, the purpose of travel might be forgotten entirely. Conflicts could arise. Factions might form, those who still believe in the journey and those who want to stop to make the ship itself their home. History could repeat itself on a smaller, colder scale, civilizations rising and falling within a metal womb drifting through space. And yet, there's beauty in this melancholy vision. The generational arc is not just a ship, it's a mirror of humanity. It reflects both our resilience and our fragility. Even if we forget our purpose, we continue. Even if we lose sight of our origins, we still create meaning. The crew of such a vessel might build art, music, and culture unlike anything on Earth. They might redefine what it means to be human, crafting a new identity shaped by their environment, a species of travelers whose home is motion itself. When the ship finally reaches its destination, if it ever does, its inhabitants may not recognize it as the goal. The descendants of explorers may look upon a new sun and feel no awe, no joy, only confusion. For them, the stars were never something to chase. They were simply the scenery of their lives. The dream of the generational arc is both a testament to our imagination and a warning about our memory. We can build vessels large enough to carry life, but can we build stories strong enough to carry purpose? Can we preserve meaning across centuries of silence and isolation? Perhaps that's the real challenge of interstellar travel, not surviving the distance, but surviving time itself. Because no matter how far we go, it's not our engines that define us. It's our reason for leaving. And in the endless night between stars, that reason can be the first thing to fade. At near light speed, time for travelers slows, but the universe outside rushes forward. 1,000 years could pass on Earth while months pass aboard the ship. When they return, home will be ancient history. This is one of the most beautiful and heartbreaking paradoxes in physics. Einstein's gift and curse to dreamers of the stars. Time, it turns out, is not universal. It bends and warps under speed and gravity, stretching for some and contracting for others. To move faster is to move differently through time. For those who stay behind, the seconds flow steady and familiar. But for those who cross the cosmic sea at near light speeds, time becomes elastic, a thread stretched thin by motion. Imagine it. A ship leaves Earth, accelerating to 99% the speed of light. The crew experiences only a few years of travel. They sleep, wake, and watch the stars shift in their windows. But when they return, 10 centuries have passed on Earth. The civilizations they knew are gone, their languages evolved, their cities buried under new ones. Even the constellations in the night sky have changed shape. The travelers would step out of their vessel into a world that no longer remembers them. This is the relativity trap, a door that opens one way. It gives us the power to move quickly across distance, but it steals the synchrony of time. Every journey at near light speed is also a journey into the future, a form of time travel that comes at an unbearable cost. Everything you love ages without you. In theory, it's possible. We've confirmed it with clocks flown on jets, with particles accelerated in labs. Time slows for motion. For cosmic travelers, it becomes a cruel form of preservation. You can escape time's decay for yourself, but not for anyone else. The universe outside your ship will live, age, and die while your own clock barely ticks. For a traveler, the loneliness of this would be unimaginable. To see the stars as they once were, to move through a galaxy that feels frozen in time while knowing that the rest of humanity has already become history. To return home and realize that home is now a concept, not a place. The relativity trap makes us question what we really mean by travel. Is it exploration, if the world you return to no longer exists? Is it connection, if every message you send or receive is centuries out of sync? At that scale, the idea of coming back loses its meaning entirely. Some have suggested that the only way to escape the relativity trap is not to return at all. To accept that such journeys are one-way trips into the future. The explorers of tomorrow may not be travelers as we imagine them, but witnesses of time's passing, ambassadors from one age to another. They wouldn't return to Earth, they would become history themselves. And yet, perhaps there's a strange beauty in that fate. To live as a bridge between centuries, to see a universe that no one else ever could, to become proof that time itself can be stretched by human will. The relativity trap is a reminder of what it truly means to move forward. Every step we take toward the stars also takes us further from the moment we came from. In chasing the light, we lose the past. And maybe that's the price of touching eternity. Gigantic mirrors pushed by starlight could one day glide toward the nearest stars. Yet even at a fifth of light speed, the journey would still take decades, and the sails would erode under cosmic dust. The photon sail, also called a light sail, is one of the most elegant and poetic ideas ever imagined for space travel. Unlike rockets that burn fuel or reactors that harness fusion, a light sail moves by catching the gentle pressure of light itself. Every photon that strikes it transfers a tiny push, a whisper of momentum. Alone, it's barely perceptible. But with billions of photons striking every second, over years and decades, that whisper becomes motion. Imagine a sail as vast as a city, impossibly thin, perhaps only atoms thick, stretching across kilometers of space. Sunlight, lasers, or even the light from distant stars would push against it, propelling the ship forward. It's a vessel with no engine, no fuel tanks, no exhaust, just pure grace, gliding silently on the tide of light. The concept is not just fantasy. Organizations like Breakthrough Starshot are already exploring it, designing microprobes small enough to be pushed to a fraction of light speed by powerful Earth-based lasers. In theory, a fleet of such probes could reach Alpha Centauri in just over 20 years. For the first time, interstellar travel feels almost within reach, not with roaring engines, but with silence and patience. But light, for all its purity, is merciless. The faster a sail moves, the more it collides with the invisible debris of the universe. Dust, gas, and radiation, each a bullet at near relativistic speeds, tear holes through the thin material. What begins as a gleaming mirror would soon become pitted, scarred, and shredded by the harshness of interstellar space. The sail that started pristine and silver might end its voyage as a tattered ghost, limping toward its destination. And then there's the problem of control. A sail that spans kilometers would be as delicate as a spider's web, easily warped or twisted by uneven light. A single micrometeor impact or burst of radiation could send it tumbling out of alignment, lost forever to the void. Steering it would require near-perfect precision, thousands of sensors and adjustments every moment to keep it facing the right direction. Even then, the faintest imbalance could spell disaster. Despite these challenges, the idea remains deeply human. The photon sail is the modern echo of ancient exploration, the way our ancestors once crossed oceans by capturing the wind. The sea has changed, but the principle endures. We are still creatures who long to ride unseen forces toward the unknown. If such a sail were ever launched, its journey would be silent and irreversible. It would pass the planets in days, leave the sun behind in weeks, and then glide through the interstellar dark for decades, carrying a sliver of humanity's curiosity with it. No crew, no voices, no returning message, just the steady pull of light, the faint acceleration of hope. Perhaps one day, a distant world will see it arrive, a fragment of silver drifting out of the black like a fallen star. And in that moment, they might understand something about us, that even in a universe of endless distance, we found a way to move forward using the only thing that truly reaches everywhere: light itself. Teleportation through quantum entanglement sounds magical, but it can't move matter, only information. You could copy yourself light years away, but the original you would still remain behind. For decades, science fiction has dreamed of teleportation, instant travel from one place to another, crossing impossible distances in a heartbeat. The idea feels like liberation, the ultimate escape from gravity, distance, and time. But when quantum physics finally gave us a glimpse of something like it, the truth turned out stranger and far sadder than we imagined. Quantum entanglement is one of nature's most mysterious phenomena. Two particles can become linked in such a way that the state of one instantly affects the other, no matter how far apart they are. Change one, and the other responds, across light years, seemingly ignoring the universe's speed limit. It's as if the particles share a silent conversation that no distance can interrupt. This discovery shook physics, hinting at a hidden web of connection woven through reality itself. But this connection doesn't move matter, it only shares information. When scientists talk about quantum teleportation, what they mean is the transmission of quantum states, the blueprint of a particle, not the particle itself. To teleport a human being, every atom in your body, about 1,028,1028 of them, would need to be scanned, recorded, and transmitted as information to another location. There, that information could, in theory, be used to reconstruct a perfect copy of you using raw materials. The problem? The original would still be here. That's the heart of the quantum paradox. If you were copied this way, every neuron, every memory, every cell, would that copy be you, or just an imitation that believes it's you? The moment you press the button, would you be transported or killed, replaced by an echo? It's the oldest philosophical question in the language of modern physics. Is identity bound to matter or to information? Even if the process were perfect, and every atom rearranged flawlessly on the other end, something essential might still be lost: the continuity of consciousness. The you who steps into the machine would never wake up on the other side. Only a version of you would. The traveler would die, so the copy could live. For interstellar distances, quantum teleportation is even more impossible. Entanglement can't send data faster than light. The two ends of the system must still exchange information through classical channels. No matter how clever the setup, the signal delay across light years would make true instant travel unattainable. Quantum mechanics can cheat many rules, but not that one. And yet, the dream persists because entanglement offers something deeper than teleportation: connection. It shows us that the universe is not a collection of isolated points, but a web of relationships. Every atom, every photon, may be part of an unseen network that binds reality together. The quantum paradox reminds us that what we long for, escape, transcendence, immortality, may not come through physics, but through meaning. We can't send our bodies across the stars, but our thoughts, our voices, our signals, they already travel, riding on waves of light rippling through time. Perhaps one day, long after we're gone, some distant mind will receive those signals and rebuild a version of us from the fragments we left behind. Not the same bodies, not the same minds, but echoes of who we were. In the end, the quantum paradox teaches a gentle truth. Maybe we were never meant to leave ourselves behind at all. Maybe we were meant to realize that the universe, in its infinite entanglement, has already connected us to everything we've ever hoped to reach. Stars are both creators and prisons. Their gravity binds their planets, their energy makes life possible. To leave one system means abandoning the furnace that gave you breath. Every living thing we know exists because of a star. From the hydrogen in our cells to the warmth on our skin, every heartbeat, every breath, every spark of consciousness is powered by the light of a distant fire. The sun is our parent and protector, the source of all motion and meaning within our cosmic neighborhood. And yet, for all its generosity, it also holds us captive, its gravity wrapping every planet, moon, and comet in invisible chains. To leave the sun's domain is to defy that ancient bond. It means stepping away from the light that made us. Beyond its reach, warmth fades into silence. The familiar glow becomes just another point in an indifferent sky. And we, creatures of sunlight, would drift into the cold. But even stars are mortal. They burn their fuel in predictable stages, fusing hydrogen into helium, helium into carbon, until the balance of pressure and gravity collapses. For smaller stars like ours, death comes softly, over billions of years. The outer layers drift away in veils of color, leaving behind a white dwarf, the cooling ember of what was once a sun. For others, the ending is far more violent. Massive stars collapse under their own weight, detonating as supernovae that scatter the elements of life across the galaxy. It's in those fiery deaths that the building blocks of everything we are born. Carbon, oxygen, iron, calcium, the elements of blood and bone, are the ashes of stars that died long before the Earth existed. We are literally made of stardust, shaped by the death of suns that no eye will ever see. Their destruction is our creation. But this cycle has a cruel symmetry. Just as stars give birth to life, they also set the limits of it. Our sun, though steady and kind, will not burn forever. In about 5 billion years, it will expand into a red giant, swallowing Mercury, Venus, and perhaps even Earth. The oceans will boil, the air will vanish, and the last traces of human history, if they still exist, will melt into vapor. It's a distant future, yet it defines the boundary of all we know. Every world that circles a star lives by its clock, its lifespan bound to the slow ticking of fusion deep within its core. To leave one star is not simply to travel, it's to trade one future for another, one dying sun for a younger flame. And so, every interstellar journey begins and ends with death, the death of stars, the death of worlds, and the death of the idea that anything can last forever. Perhaps that's what makes the light so precious. It shines only for a while. When we look up at the night sky, we're not just seeing stars, we're seeing time itself. Some are newborns, others already gone, their light still racing toward us across millennia. To gaze at them is to witness creation, and destruction at once. In that way, the death of stars reminds us of our own fragility and our inheritance. We are the children of their fire, the heirs of their ashes, and if we ever leave this solar system behind, we'll be carrying their story with us, the memory of suns that died so we could live, and the quiet knowledge that even the brightest light must one day fade into the dark. Even if one day we escape the sun entirely, the galaxies themselves drift apart. The cosmic expansion is relentless. Someday, even light won't bridge the gap between them. When we look up at the night sky, we see a universe filled with light, billions of galaxies glowing across unimaginable distances. But what we don't see is how quickly it's all slipping away. The cosmos is stretching, expanding faster and faster, driven by a mysterious force we call dark energy. Every second, the space between galaxies grows. Every second, the universe becomes larger, emptier, colder. At first glance, this expansion seems harmless. After all, the stars above us haven't changed. The constellations still form familiar shapes. But on the grandest scales, galaxies are racing apart at incredible speeds, so fast that beyond a certain point even light cannot close the distance. That point is called the cosmic horizon, and it defines the ultimate boundary of what we can ever see or reach. Anything beyond it has already vanished from our universe forever. If humanity could somehow escape our solar system, and even our galaxy, the dream of endless exploration would still collide with this invisible wall. Beyond the Milky Way lies the local group, a cluster of galaxies bound together by gravity, Andromeda, Triangulum, and a few dozen smaller companions. But even this small family is surrounded by darkness. Beyond its edge, space itself is stretching so quickly that no force can overcome it. Billions of years from now, as expansion continues, distant galaxies will slip over the horizon one by one. Their light will redshift, stretching into longer and longer wavelengths until it fades completely. Future observers, if any still exist, will look up and see only the empty blackness of their own galaxy, isolated in an ocean of nothing. The universe will seem smaller, lonelier, even though it has grown unimaginably large. This is the fate cosmologists call the eternal night, a future where every galaxy becomes an island, drifting through an ever-expanding sea of darkness. Communication between galaxies will become impossible. Even light itself, the fastest thing in existence, will be stranded, its messages forever stretched and silenced by the swelling fabric of space-time. In that far future, there will be no way to know that other galaxies ever existed. No starlight, no cosmic background radiation, no evidence of the Big Bang. The universe will appear empty and eternal, its origins erased by its own expansion. Civilization, if it still survives, will live under a sky without stars. It's a haunting thought that the cosmos, once filled with light and connection, will one day dissolve into isolation. Every sun, every world, every trace of our existence will drift apart until even the memory of light fades. And yet, there's beauty in this melancholy fate, because right now, we live in the age of light, the brief moment when galaxies still shine to one another, when the universe still reveals its vastness. We are witnesses to a cosmos alive and luminous, a universe that still speaks across the dark. To gaze at the night sky is to see something future beings will never know, a universe full of neighbours, bound together by gravity and light. The eternal night between galaxies is still far ahead. For now, the stars still call to each other, and to us. Dark energy, dark matter, and the geometry of space itself, all unknown frontiers that warp our ability to move. The deeper we look, the more the universe reminds us. We don't understand the rules. For all our progress, for all our equations and telescopes and brilliant minds, we've barely scratched the surface of what the universe truly is. We build models, we name forces, we simulate the cosmos in computers, but beneath it all lies mystery. 95% of everything that exists is invisible to us. The matter that makes up stars, planets, and people is only a faint trace, an afterthought in a much stranger creation. Take dark matter. It doesn't glow, it doesn't absorb, and it doesn't reflect light. Yet, it reveals itself through gravity, shaping galaxies like an unseen hand. Without it, the stars would fly apart. With it, they cling together in graceful spirals. Every time we look deeper into the night, we see its fingerprints in the motions of galaxies, in the bending of starlight, in the invisible scaffolding that holds the universe in place. But we still have no idea what it is. Then there's dark energy, the even greater enigma. It's not just invisible, it's everywhere. A pressure woven into the very fabric of space, pushing galaxies apart faster and faster. It behaves like the opposite of gravity, a silent expansion that will one day drive all things beyond each other's reach. We don't know where it comes from, why it exists, or whether it will remain constant forever. Yet it controls the ultimate fate of everything. Even the geometry of space itself defies intuition. On human scales, the universe feels flat, predictable, Euclidean. But on cosmic scales, it curves and stretches, ripples and bends. Space and time are not separate entities, they are a single fabric, molded by energy and mass. Every planet, every star, every particle alters that fabric ever so slightly. Motion is not movement through space, but a dance across a warped, shifting field we can never fully see. When we talk about leaving the solar system, we imagine traveling in straight lines, but in reality, there are no straight lines in the cosmos. Every trajectory is bent by gravity, time, and the unseen flows of dark energy. The deeper we peer into the structure of the universe, the less sense distance makes at all. Some scientists suspect that our understanding of physics, our most sacred foundation, is incomplete. Quantum mechanics and general relativity, the twin pillars of modern science, still refuse to reconcile. One governs the small, the other the vast, and somewhere between them, truth breaks. Perhaps what we call space and time are not continuous but granular. Perhaps the speed of light, that ultimate limit, is only a local rule, not a cosmic constant. At the edge of physics, every certainty begins to blur. The universe stops being a machine and becomes something more elusive, alive with paradox, governed by laws that may shift as we uncover them. Every answer leads to another question, and every discovery deepens the mystery. It's humbling to realize that all our technology, all our knowledge, all our dreams of travel are built upon an incomplete understanding of reality itself. We are explorers sailing a cosmic ocean whose depths we cannot yet measure, guided by maps that might be wrong. And maybe that's the truest form of wonder, not knowing, because if we ever did understand every rule, every force, every constant, the universe would lose its magic. The edge of physics is not a boundary, it's an invitation. A reminder that the cosmos still holds secrets vast enough to keep us reaching, questioning, and dreaming beneath the stars. Far beyond Pluto, our machines drift in silence, tiny sparks of human will floating in eternal dark. Voyager 1 and Voyager 2 were never meant to become legends. They were launched in 1977, built with the technology of their time, 8-track tape recorders, computers weaker than a modern calculator, and golden records carrying greetings in dozens of languages. Their mission was simple: explore the outer planets, take pictures, and send the data home. But fate had a grander story in mind. Decade by decade, they travelled farther than any human creation before them. Past Jupiter's storms, Saturn's rings, Uranus's icy moons, and Neptune's blue winds. Each planet they passed became a chapter in a story written across billions of miles. Then, with their primary mission complete, they kept going. No destination, no return, just the slow, steady drift toward the edge of the sun's reach. Voyager 1 crossed the heliopause in 2012, entering interstellar space. It was the first object made by human hands to truly leave our solar system. Out there, the sun's wind fades to nothing, replaced by the faint whispers of cosmic radiation and the cold breath of the galactic void. The spacecraft's radio signal, weaker than a whisper, still reaches us, a thread of information stretched across more than 15 billion miles. It takes over 22 hours for that faint pulse of data to arrive. Every bit of it, every pixel, is a heartbeat from the edge of forever. Yet, despite their distance, the Voyagers remain loyal. They still speak, though their voices are fading. Their power comes from decaying plutonium, and each year, their instruments grow dimmer. Eventually, one by one, their systems will go silent. First the cameras, then the sensors, then the radio. Finally, only the cold shell will remain, drifting endlessly between the stars. Each carries a message, a golden record etched with sounds and images of Earth. Whale songs, thunderstorms, a mother's laughter, a baby's cry. Greetings in 55 languages, the music of Bach and Beethoven, the heartbeat of a species that longed to be known. Those records are time capsules, waiting to be found by someone or something that might one day listen. But the truth is, the Voyagers will likely never be found. The universe is vast beyond comprehension, and they are smaller than dust compared to the distances they travel. They will outlive our cities, our civilizations, even our species. Long after the last human voice has faded, those two small machines will continue to drift. Silent ambassadors of a world that once dreamed of the stars. There's something almost spiritual about that. In a way, the Voyagers are our ghosts, fragments of our will still moving outward when everything else stays behind. They are proof that humanity once dared to reach beyond its cradle, that we once pointed our machines and our hopes toward infinity. And maybe that's enough. Maybe leaving a trace, however small, is the truest form of travel. Because even if we never follow, the ghosts of Voyager remind us that we were here, that once, long ago, on a small blue planet circling a yellow star, life looked up at the night sky and said go. The farther we reach, the lonelier it becomes. No radio, no light, no echo of home. Space is not just distance, it's the sound of forever. Isolation in space isn't just about being far from others, it's about the absolute absence of everything. Beyond the heliosphere, beyond the faint whisper of solar wind, there is no air to carry sound, no medium to transmit touch, no presence to reassure you that something else exists. The universe becomes a vast and perfect silence. It's a place where even light feels slow, and the concept of home becomes more memory than reality. For all our achievements, we've barely stepped beyond our front yard. Every spacecraft we've sent outward still travels under the fading glow of the sun, clinging to the last traces of its warmth. Beyond that light, the dark is complete. There is no up or down, no morning or evening, only a timeless expanse where direction loses meaning and motion feels like standing still. Astronauts often describe a strange feeling when looking down on Earth, the overview effect. From orbit, they see the thin blue line of the atmosphere, the fragile curve of our planet, and realize how delicate everything truly is. But imagine looking back when Earth is no longer visible at all, when even the sun has dimmed to a distant spark. That would be more than awe. It would be the purest loneliness ever known. If a human were ever to travel far enough from the solar system, communication would become impossible. A radio signal from that distance would take years, even decades, to reach us. And when it did, it would be so faint, so buried in cosmic noise, that it might never be heard. Each message would be a bottle cast into an infinite ocean, drifting endlessly with no guarantee of reply. The isolation isn't just physical, it's emotional, psychological, spiritual. Humans evolved in the company of others. Our sense of identity is woven from interaction, voices, touch, warmth, the shared rhythm of living things. Space erases all of that. In the interstellar void, there would be no sound but the pulse of your own heart, no light but the reflection of your own ship. You would become your own entire world. Even our machines feel this isolation. The signals from Voyager, Pioneer, and New Horizons are like the fading heartbeat of a civilization trying to whisper across eternity. Their data takes hours or days to arrive, and one day soon, their transmissions will cease completely. When that happens, they will continue in silence, forever unhearing, forever unseen. And yet, there's something hauntingly beautiful in that silence. Because in it, we find reflection. The universe isn't empty, it's vast, waiting, patient. It listens, even if it doesn't respond. Every radio wave we've ever sent, every television broadcast, every signal of curiosity and love is still traveling outward, expanding through the dark like ripples in an endless pond. We've filled the void with echoes of ourselves, even if we'll never hear them return. Cosmic isolation reminds us that space is not a place designed for life. It's a mirror for life to recognize itself. The farther we travel, the more we see how rare connection truly is, how miraculous it is that we ever found companionship on one small world. Maybe that's what gives the silence its meaning. It's not the absence of sound. It's the presence of perspective. A reminder that, in a universe where everything drifts apart, finding anyone or anything to share a moment with is the most extraordinary miracle of all. Every second, the universe grows. Galaxies recede faster than any engine can chase them. With each heartbeat, the reachable cosmos becomes smaller. It's one of the most sobering truths in all of science. The universe is not static. It's not even merely drifting apart, it's accelerating. Every moment, space itself stretches, carrying galaxies away from one another like dots on the surface of an inflating balloon. And the faster that balloon expands, the less any of those galaxies can ever reconnect. This expansion isn't happening in space, it's happening to space. The galaxies aren't flying through a pre-existing void, the void itself is growing between them. Every meter of space doubles, triples, expands, dragging matter and light along for the ride. It's not the galaxies that move, it's reality itself that flows. At small scales, gravity still wins. The planets orbit the sun orbits the center of the Milky Way, and the Milky Way, along with our neighbor Andromeda, remains gravitationally bound. Together, they form a small island in the cosmic ocean, a cluster of light that will cling together for billions of years. But beyond that island, the tides of expansion roar, unstoppable and eternal. Galaxies beyond our local cluster are already slipping away faster than we can ever hope to reach them. Their light still arrives, but stretched, redshifted, by the expansion of space. Every photon travels farther, grows weaker, until one day it disappears entirely from view. It's as if the cosmos itself is pulling a curtain across its most distant edges. This means that every year, every second, the observable universe becomes smaller, not in size, but in accessibility. There are places that we can see today that no one, ever, will be able to reach. They are already gone, not in time, but in causality, beyond the limits of influence, beyond the reach of light, beyond the possibility of travel. Even if humanity built a ship that could travel at 99.999% the speed of light, it wouldn't matter. The fabric of space would still outrun it. The expansion doesn't care about engines, propulsion, or determination. It's a property of the universe itself, a law written into the geometry of existence. It's a strange, almost poetic imprisonment. The faster the universe expands, the less of it we can touch. Someday, distant galaxies will vanish entirely from our sky, their light stretched into invisibility. The night will grow emptier, the stars fewer, until only the faint glow of our own galaxy remains, a single island in an endless dark sea. For any beings who live in that distant future, the universe will seem small and ancient. They will see no trace of other galaxies, no echo of the Big Bang, no evidence of expansion. Their physics will tell them they are alone in a cold, static cosmos. The truth that the universe was once bright and filled with neighbors will be lost to time. And yet, we exist now, in the luminous moment between darknesses. We are alive during the brief era when the universe still speaks to itself, when galaxies still share their light. Every telescope, every photon, every discovery is part of a fleeting window of cosmic awareness before silence returns. The universe expands faster than we can travel, but perhaps that's what gives meaning to our journey. To explore is not to conquer distance, but to witness a moment that will never come again. Because in a universe that's always moving apart, every glimpse of light, every act of wonder is already a form of farewell. We imagine ourselves as explorers, yet we exist within limits so vast that no ship, no technology, no dream can break them completely. Scale itself is the ultimate cage. The more we learn about the cosmos, the more we realize how profoundly small we are, not just in size, but in reach. Between every star lies trillions of miles of darkness. Between every galaxy, trillions of trillions more. And beyond them all, the silent fabric of space continues without end. Even light, the fastest thing in existence, is too slow to keep up. The distances are not just large, they are impossible. When you zoom out from the solar system, the planets vanish almost immediately. Another zoom, and the sun becomes a mere dot among countless others. Zoom farther still, and the Milky Way itself fades into a hazy thread woven through a tapestry of galaxies. Each one of those galaxies holds billions of stars. Each of those stars, perhaps, a home. And yet, in the vastness between them, there is almost nothing. The scale of emptiness is overwhelming. If we could travel faster than any rocket ever imagined, 10,000 times faster than light itself, it still wouldn't be enough. The universe is expanding, stretching faster than anything can cross. The further you go, the further it becomes. Motion itself begins to feel futile, like trying to swim against an infinite tide. And yet, the prison of scale isn't just about distance, it's about perception. Our entire understanding of existence is built from human-sized experiences. We think in terms of meters, seconds, years, but the cosmos moves in billions, of light years, of centuries, of lifetimes. To truly grasp it requires stepping outside what the human mind was ever built to hold. And when we try, we find ourselves humbled, even frightened, by the sheer immensity of it all. We build spacecraft, telescopes, and equations to measure the infinite. But every discovery only makes the cage larger. We see farther, yet we touch nothing. We know more, yet control less. The irony of progress is that it reveals our limits more clearly than our possibilities. The deeper we explore, the more the universe reminds us that it is not built for us, that we are guests, not masters, in a reality far beyond comprehension. Even the smallest things obey this cruel symmetry of scale. The quantum world beneath our feet is as unreachable as the galaxies above our heads. At the tiniest distances, the rules of nature bend and blur, just as they do at the grandest. Somewhere between those two infinities, between the unreachable small and the unreachable vast, is us, suspended in the middle. We are trapped between the microscopic and the cosmic, between particles and galaxies, between beginnings and endings. The prison of scale surrounds us completely. And yet, it is a beautiful cage, one made of light and time and the endless reach of curiosity. Because even if we can't escape it, we can still see it, we can still know it. Perhaps is humanity's quiet defiance against scale itself. We may never break the cage, but by understanding its walls, by tracing its edges with thought and imagination, we make the infinite just a little more familiar. In the end, the prison of scale doesn't diminish us, it defines us. For in a universe so vast that even light cannot cross it, the simple act of awareness, the ability to look up and wonder, is itself a kind of victory. Billions of years from now, our sun will expand and die, taking Mercury, Venus, and perhaps Earth with it. Even if humanity survives elsewhere, we will still belong to this fading star. Every story we've ever told, every breath we've ever taken, every heartbeat that's ever pulsed through human history, all of it has unfolded under the light of one star. The sun is more than a source of energy. It is our origin, our constant companion, our silent witness. Its gravity holds us close. Its warmth gives life to oceans, forests, and skin. We are, in the most literal sense, children of its fire. But like all living things, even stars grow old. The sun is now middle-aged, about 4.6 billion years into its life. For billions more, it will continue to burn hydrogen into helium, steady and predictable. But deep within its core, change is already happening. Slowly, imperceptibly. It grows hotter, brighter, more volatile, and one day, the balance will break. Roughly 5 billion years from now, the sun will run out of hydrogen in its core. It will begin to fuse helium instead, expanding outward into a red giant, its diameter swelling hundreds of times larger than it is today. Mercury and Venus will be the first to go, swallowed whole by the widening inferno. Earth's fate is less certain. But even if it isn't engulfed, its oceans will boil, its air will vanish, and its surface will glow red-hot beneath an alien sky. From a distance, our solar system will transform into a graveyard of light. The planets will drift farther out, their orbits twisted by the sun's changing mass. Moons will lose their balance, asteroids will scatter, and comets will melt in long, brilliant arcs. The familiar will become unrecognizable. The sky we know, the sun that defines our days, will cease to exist. But death is not the end for stars. When the red giant's fire finally cools, its outer layers will drift away in waves of color, a planetary nebula, expanding into the void like a cosmic flower. At its center, the sun will shrink into a white dwarf, a core no larger than Earth glowing with the last remnants of its heat. For trillions of years it will fade, cooling until it becomes invisible, a dark ember lost among the stars. Even if humanity survives, on other planets, in other systems, or in forms beyond our imagination, we will never escape our parent star's shadow. Its light will always be written into us. The carbon in our bodies, the calcium in our bones, the energy that fuels our thoughts, all of it was once sunlight, transformed by life into memory. To watch the sun die would be to witness the closing of the most ancient chapter in our story. And yet, there's beauty in that ending. The death of a star is also a creation, a release of elements and energy that will seed new worlds, new suns, new beginnings. The light that once nurtured us will go on, scattered across the galaxy, forming the next generation of stars and planets. In that sense, the sun's final light will never truly fade. It will live on in other skies, in other hearts, in the slow unfolding of time. Even if we travel far beyond its reach, we will always carry a trace of its warmth, a memory of the golden dawn that once rose over a small blue world, and the star that taught us what it means to shine. Maybe the reason we cannot leave is that we are not meant to. The atoms in our bodies were forged in the sun's furnace. Every heartbeat is a pulse of its ancient light. For all our yearning to escape, to go farther, faster, beyond the edge of what's known, there is a quiet truth that lingers beneath the dream. We are not separate from the place we come from. We are it, in another form. The air in our lungs was once the breath of volcanoes. The calcium in our bones was born in the death of stars. The water in our veins has cycled through clouds, rivers, and oceans for billions of years. To leave Earth, to leave the sun, is not just to travel through space, it is to walk away from everything that built us. The paradox of belonging is that we dream of freedom while being made of captivity. Our bodies are tuned to Earth's gravity, our eyes to the warmth of daylight, our minds to the rhythm of its rotation. Even our sense of time, the very structure of our lives, comes from this planet's spinning dance beneath the sun. We are synchronized to its pulse, like notes in a song that cannot be played anywhere else. If we ever set foot on another world, we will bring Earth with us. Its microbes, its atmosphere, its language, its memory, all of it will travel in our DNA, in the architecture of our cells. We will terraform other planets not just with machines, but with ourselves. Every breath we exhale will be an echo of the forests that once sustained us. Every heartbeat will still carry the sun's signature, the rhythm of the home we can never truly escape. Perhaps that's why, for all our exploration, we have never found a place that feels quite right. Mars is close, but it's cold and airless. The moons of Jupiter and Saturn shimmer beautifully in the dark, but their radiation belts would kill us. Even the most Earth-like exoplanets we've discovered are distant beyond imagination, too far to ever touch, too faint to ever call home. The universe may be filled with worlds, but none of them are ours. And maybe, deep down, that's the point. Maybe we are not meant to wander forever. Maybe the universe designed us as caretakers of one world, not conquerors of many. Our connection to Earth is not just biological, it's spiritual, gravitational, atomic. We don't simply live on this planet, we are this planet, temporarily arranged into thought and form. To belong, then, is not to be trapped, it is to recognize the miracle of alignment. Against impossible odds, the cosmos gave rise to a place where starlight could think about itself, where dust and fire could become consciousness. That place is here. This single fragile sphere, orbiting an ordinary star in a quiet arm of the Milky Way, is where the universe learned to look back at itself and wonder. The paradox of belonging is that to dream of leaving is part of who we are, but so is the inability to truly let go. We are bound by gravity and love in equal measure, and perhaps, in that balance, there is peace. Because even if we never cross the stars, we have already touched infinity by simply existing here as the cosmos made aware of its own home. Perhaps our greatest journey isn't outward, but inward, to understand that every cell, every thought is a reflection of the cosmos that birthed us. To explore the universe is to explore ourselves. We often look to the stars as though they are far away, distant, and unreachable. But the truth is, they have never truly been separate from us. The universe does not just surround us, it flows through us. Every atom in your body, every flicker of thought in your mind, carries the story of creation written in its structure. You are the cosmos, condensed into awareness. When you breathe, you take in atoms that once drifted through ancient atmospheres, that once belonged to oceans, forests, and even other beings. Some of the oxygen in your lungs may have been part of a comet. Some of the carbon in your skin once resided in a long-dead star. You are not merely in the universe, you are of it. The hydrogen that fuels your cells was born in the Big Bang more than 13 billion years ago. The calcium in your bones was forged in the heart of a dying star. The iron in your blood once flowed in rivers of stellar fire. When you look up at the sky, you're not just looking outward, you're looking into your own history. The universe lives inside you, whispering its story through the architecture of your being. For centuries, we've searched for meaning in the heavens, thinking that the truth lay somewhere far beyond our reach. But perhaps the deepest truths are not found in telescopes or distant galaxies. They are found in reflection, in consciousness itself. The ability to ask, "What am I?" is not just philosophy, it is the cosmos questioning its own existence. Neuroscientists sometimes describe the human brain as the most complex structure in the known universe. Inside your skull, trillions of connections spark and fade like tiny galaxies, each thought a pulse of energy that mirrors the rhythm of stars being born and dying. When you dream, when you imagine, when you love, you are performing the same act the universe has done since its beginning, creating something new from chaos. Maybe that is the real purpose of our curiosity, not to conquer space, but to understand that we already belong to it. Our exploration of the cosmos is really a mirror for our exploration of ourselves. The same laws that govern galaxies govern the synapses in our brains. The same dance of energy that binds planets in orbit binds us in emotion, memory, and connection. If we could truly comprehend that unity, we might see how little separates here from out there. The universe doesn't end at the edge of space. It continues within every heartbeat, every atom, every spark of awareness. The frontier we've been chasing through rockets and telescopes has always existed inside us. Perhaps then the most profound act of exploration is stillness, the moment when we stop reaching outward and realize that we already carry the infinite within. To know ourselves is to know the universe, because in truth they are one and the same, different expressions of a single, timeless mystery trying to understand itself. The stars are not just above you, they are in you. You have always been their echo, the universe dreaming in human form. That isn't distance, or physics, or time. It's that we already are the universe. To leave the solar system would be to leave ourselves behind. The stars aren't destinations, they are mirrors. For all our striving, for all our rockets, our mathematics, our restless longing to wander beyond the horizon, perhaps the truth has been quietly waiting for us all along. We look to the sky and call it elsewhere. We speak of out there, as if the cosmos were something foreign, something to conquer. But what if it isn't? What if the universe has never been something to travel through, but something to awaken within? Every atom that builds us, every thought that rises in our minds, every flicker of electricity that sparks behind our eyes, each is a piece of the universe reflecting on itself. We are not observers standing apart from the cosmos, we are its continuation. The solar system is not our cage, it's our context. The same starlight that feeds the planets feeds us too. We imagine leaving as an act of freedom. But freedom, in its truest sense, might mean recognizing that we've never truly been trapped. The stars we dream of reaching are made of the same light that burns inside us. Their gravity is our gravity, their matter, our matter, their history, our story. There is no edge to cross, because the boundary between us and everything else has never existed. And so, when we speak of never leaving our solar system, it's not a confession of failure, it's a revelation of unity. We can travel across space, we can send ships and signals and dreams to the edge of the interstellar dark. But we will always remain what we are, a fragment of the same whole, turning in quiet harmony with all things. Even if, one day, our descendants walk under alien suns, the light that warms them will still be our sun's cousin, born from the same cosmic nursery. Even if our civilization stretches across galaxies, every molecule they breathe will still carry the memory of this one small star that gave us life. The real reason we'll never leave is not that we can't. It's that there is nowhere else to go. Every corner of the universe is made of the same fabric, the same atoms, the same silent laws that shaped us. No matter how far we drift, we are always home. The stars have never been destinations. They are mirrors, ancient, patient, waiting for us to see ourselves in them. To leave the solar system would not be to escape, but to return, endlessly, to the same realization. That the universe does not exist around us. It exists as us. Perhaps that's what the cosmos has been whispering all along. Not go farther, but look closer, because the greatest discovery is not across the stars, it's in the simple, stunning truth that we were never apart from them to begin with. And so, we drift back to where it all began. A small blue world, circling a quiet yellow star, our island in the cosmic sea. We've travelled, in thought if not in body, to the edge of time and understanding. We've seen the limits of distance, the silence between galaxies, and the fragile miracle that binds us to this place. For all the equations and engines, for all the dreams of flight and fire, maybe the greatest truth is also the gentlest one, that we already belong. We are not strangers in the universe. We are its reflection, made of its dust, warmed by its light, breathing its rhythm with every heartbeat. When you look up tonight, know that you are not looking outward. You are looking inward. Each star is a memory of where you came from and where you will return. The sun that rises tomorrow will be the same ancient fire that once forged your atoms, the same glow that will someday fade into the dark, and yet, in that fading, give birth to something new. We may never leave our solar system, but perhaps we were never meant to, because to understand it, to marvel at it, is to already be part of something infinite. The stars do not wait for us to arrive. They live within us, quietly burning, reminding us that wonder is not found in distance, but in awareness. So, wherever you are, close your eyes. Feel the hum of the universe in your chest. You are home. You have always been home. Sleep well, traveller among the stars. Until next time, let's dream again.